All right, and that completes problem number 20. We have graphed the function and its inverse, and the little dotted line I put through here shows that if you fold it, it should fold over on top of each other. Now, our next two problems, problem 21, is that we need to show that they are inverses or if they're not inverses. Well, to do that, we take one equation and plug it into the other. So I'm going to take this equation and plug it into my x right there. So negative 2/3, I'm going to put a parenthesis, and then plus the 4/3. And in my parenthesis, that's where the x is, I'm going to put what I've circled down here, 2 minus 3/2 x. Now to simplify this, which is my next step, is to simplify. I want to take this negative 2/3 times 2. That gives me negative 4/3. Again, you can use your calculator to do the arithmetic. Negative 2/3 times negative 3/2. Negative times a negative is a positive. I'll notice that I have a 2 on top and bottom. They will cancel. I have a 3 on top and bottom. They will cancel. That leaves me with 1x plus 4/3. Now when I combine these, I have negative 4/3 and positive 4/3, so they cancel, and I'm left with x. Therefore, yes, they are inverses. And that completes that problem. Number 22 is very similar, and we're going to do the same thing. I'm going to choose one and put into the other. Let's take this first one and put it into the x underneath the radical. So I have the square root, or not square root, sorry, it is a 5th root. Now I'm going to put all of that in there, and then my plus 3 right here is out here on the end. So I have x minus 3 to the 5th power. Well, the 5th root and a 5th power are inverse operations, so they cancel each other out. So I have x minus 3 that's coming from here, and then my plus 3 on the end. Negative 3 and positive 3 cancel each other out. I'm left with x. So, yes, they are inverses. To prove that something is an inverse, you take one and plug it into the other, and you should get an x, and only an x. All right. Now you have another paper, and it has a number of these problems, and it says determine if these are true or not. Well, to be perfectly honest with you, really the easiest way to do this is to merely put it in your calculator. And if I take 25 caret to the 5/3 power, nope, sorry, help if I read the problem, 3/2 power, I work that problem and I get 125.
Pardon the interruption. Austin Sharp.
Sorry for that interruption. Now I'm going to put in the 5 to the 3rd power. And you'll notice I get the same answer. If I get the same answer for both, then this is true. If I get the same answer, it's true. So let's do the next one. 36 to the 1/2 power gives me 6. Then 9 to the 3/2 power gives me 27. I don't get the same value, so this problem is false. I will continue that same process through all of these. (27) to the 2/3 power 81 to the 1/2 power. Therefore, it's true. 2 to the 6th power and 8 to the 2nd power. Both 64, therefore it is true. Even if I have a radical, I can put the, oh, sorry, I'm getting all off the screen. Even with the radical, I can put it in. Parenthesis, square root, 25, arrow out, close your parenthesis, and raise it to the 3rd power. And then 5 to the 3rd, I get the same value, therefore it is true. Not a particularly difficult process at all. Okay, 2nd square root, 36. Now cubed root. To find that cube, I'm going to go to I'm going to go to Math, and I'm going to go down to number 4. Math, and I'm going to go down to number 4 for the cubed root of 216. And I get 6 for both. So it is also true. Next one, 5 to the 4th and 25 to the 2/5. Not the same at all, so that one is false. Number 8, 125 to the 4/3 power and 25 to the 2nd power. Alright, this is a cubed root. See the little 3? So I have to make sure I go to Math and down to number 4 to get the 3rd root of 27. Arrow out. Oh, I forgot my parenthesis. I'm sorry. Let's arrow back over and put it in. Insert parenthesis. There we go. Now I'm going to put my power of 2. Gives me 9. So parenthesis. Square root of 81. Arrow out. Close my parenthesis. To the 1/2 power. And I get 3. I did not get the same value. Therefore, that is false. That is the easiest way to do this set of problems. Merely use your calculator and compare each side. Now, my next problem. To solve this, we've talked about this. I've given you this problem. Now I need to solve it. When I have 2 radicals, I need to move this to the other side. Sorry again for that interruption. So I'm going to add this to both sides. So I'll get the square root of 3x minus 4 is equal to the square root of x plus 6. And so over here for my reason, I'm going to add the square root of x plus 6 to both sides. Oh, can't fit it in. Sorry. To both sides. I write too big. To both sides. Alright. Now my next step. How do I get rid of the radical? Well, to get rid of the radical, tell me what I'm going to do. I'm going to square both sides. And so then I do that. When I square both sides, that gives me 3x minus 4 is equal to x plus 6. When I look at my problem, I see I have an x on both sides, so one of those needs to go. So I'm going to subtract my x from both sides. So subtract an x. So this gives me 2x minus 4 equals 6. Now again, I'm going to continue to get my x by itself, so I need to add my 4. Well, not just writing the add 4, I've got to put it over here. Add 4. And yet we are doing it to both sides. So I get 2x equals 10. Now to finish solving this, I'm going to divide by 2. If I divide by 2, I get x equals 5. That's going through and doing the problem and giving me the reason or the step of what you're doing. And remember that you're doing this to both sides. Both sides. Okay. Our last step, or our last problem, is here on the back. And you are to figure out which of these, let me zoom out a little bit. There we go. Which of these are equivalent to this? Well, this is division, so I have to subtract my exponents. Well, let's use my calculator. And I have 1/3 minus 2 because I'm subtracting the exponents. That gives me a decimal that I don't really want, so I'm going to go to math, enter, and I get negative 5/3. Negative 5/3. So this is x to the negative 5/3. Oh my. I believe I goofed. These are supposed to be 3s, not 6s. I apologize. When I typed that, I completely goofed. So I'm going to change all these to 3s on the bottom. And that 6 to a 3. Sorry. There we go. I apologize. Negative 5/3, which means this one is correct. So sorry. Now I can't have a negative exponent, so what do I need to do? I have to move it to the bottom. Oh, so if I move it to the bottom, it makes this one correct, but it's 5/3. Again, I apologize for goofing that up. All right, well, how do I change this out of exponential form to radical? Keep my 1 on top. That 3 is my index, and x to the 5th, so it means this one is also correct. Can't read that very well. 3/5. 5/3. This is 5/3. Negative 5/3. Oh, so sorry. That was a really big goof by me. Alright, so I have 3 correct answers right there. Again, I apologize for missing that. I just mistyped it, and I did it repeatedly. Alright, this is your review for your test. Your test is tomorrow. Please make sure that you have done everything that you need to do to be prepared for class tomorrow. And these 2 papers will be turned in for a grade. Actually, it's 3 papers, isn't it? Make sure that you turn all of this in as a grade. Thank you. Have a great day.